Swinburne University of Technology.
Okay, welcome everyone to today's CAIA seminar. Today we have visiting speaker David Wilde from AARNet, Chief Technology Officer. I did not know. Is that right?
Yep.
Oh, that got it right. So David joined AARNet, Australia's academic research network, in 2010. Hopefully everyone's aware that AARNet services the universities and higher education sector. His primary focus at AARNet has been involved in the rollout of AARNet 4, the next generation research and education network. He's had many years of experience prior to joining AARNet. He's spent years in France, building European customer base with IBM, Alcatel, L'Oreal. Has a Bachelor of Engineering and a Bachelor of Science from Monash University. He lives here in Melbourne, but more recently he's been involved in the Australian SDN Research Testbed, which is being constructed between a number of universities, including Swinburne. If anyone's walked into the lab in the back of the CAIA area, you might find that it's slowly being constructed there. But David will be talking a lot about that today. So thank you very much for coming in, David.
No worries. Thanks, Jason. Thanks for coming along today. I appreciate you making the effort. My name's David Wilde. I thought I'd talk a little bit about AARNet initially, because not everyone's heard of it, despite the fact that we connect the 38 universities and the CSIRO to the internet. It's kind of our primary aim. But increasingly we connect schools and TAFE colleges and hospitals. And down the bottom, some interesting stuff there. Research instruments. So like the square kilometre array or the synchrotron, or I guess what I'm talking about there is devices that generate data. And then cultural, which always gets a bit of a laugh when I present overseas, because they all say, oh, Australia, no culture there. But what we mean by that is galleries, libraries, archives and museums where data is stored. And so the reason that we try to connect them is because students and staff at universities want to reach that data. So really what we're about is connecting research and education across Australia to each other and to the outside world. If you go back to, I think 1989 was the first connection that AARNet brought into Australia, which was essentially a link from the United States to the University of Melbourne, because at that time there was no internet as such in Australia. Jeff Houston, if you've heard of him, who was with AARNet at the time and who is now with APNIC, who steals one of our desks up in Canberra, he was involved along with Peter Elford, who is now back at AARNet after many years. This is what our network looked like just after that. You can see, I don't know if you can see the figures, but 1.5 meg to the United States, which was for all of Australia's universities at that time. So you can kind of see that things have moved on a fair bit since then, thankfully, because we'd be pretty congested if that was still the case. So this is what our network looks like now. In 2015, or at least it did whenever I took a copy of this picture, because it goes out of date as fast as I can put it into a PowerPoint. So we have access to fibre optic cable wherever you see the red lines there, and we put our own optical networking equipment on top of that, so we can carry multiple wavelengths using WDM capability. And then sitting on top of that, we then put a routed backbone. So we've got 100 gig routers connected in all of the big black dots there. And the smaller black dots are where we hand off kind of a small number of, or a large number of customers, depending on where we are. Essentially what that means is that if you're sitting at the Square Kilometre Array telescope, which is literally in the middle of nowhere, you've essentially got 100 gigabits per second of capacity all the way to Sydney if you need it, which means that it's pretty highly connected compared to most of our homes. And then we extend that through 10 gig or other circuits to the rest of the country where we don't have access to fibre, but we're continually trying to push that connectivity out. And I guess the reason we do this is to provide flexibility to universities, and particularly to researchers within universities. We connect you to Facebook and to Google and to all that important stuff, and that's kind of the bread and butter of a university and of AARNet. But the important thing is to enable researchers. So, for instance, that the physicists at the Centre for Experimental Particle Physics at the University of Melbourne, who pull data down from the Large Hadron Collider. They do it at 10 gigabits per second, and no doubt very soon it'll be 20 or 40 gigabits per second. And that's what we need to enable, really. It's that peak capacity, which is very different to a TPG or an AARNet even, who will work on averages rather than peaks. So the way we make that work outside of Australia is by getting our own connectivity to the United States and to Asia. So we have here, and I will get to the SDN part. There is a reason for all of this talking, but I'll get there. So we have our own capacity to the United States. There are 4 10 gig links, which is for the Facebook traffic, and then there are 2 and then there are 2 40 gig links, which in 6 months' time will become 2 100 gig links, so the green ones that are purely for R&D traffic. And we peer, when you get to the next slide, we peer with all these red dotted lines, which are artist's impression of other networks like AARNet. So every country has got a research and education network to the most extent. And so we peer with them, which means that if you're sitting here at Swinburne, download data from MIT or from Oxford University or from the University of British Columbia, your traffic actually goes across research and education networks the whole way there. It never touches commercial telcos like Telstra, for instance, or their equivalents overseas. So that same approach that we take, which is to give lots of bandwidth, all the R&D networks try to take that same approach, and that means that you as a researcher, wherever you are in Australia, will have that, ideally, unconstrained bandwidth to any other research destination in the world. In reality, it doesn't always work like that. We're constrained by what's available in terms of fibre, and so if I go back a slide here, you can see these little dotted lines here. At the moment, yes, we have, 240 gig of capacity that way. Over this way, we've got 5 gig, and that's just because the cable systems into Asia don't support anything more or less. But we're in the process of working on solutions to that. It just means that we need to be clever about which way we send traffic. Long way around with lots of bandwidth, or short way with not much bandwidth. And I'll get back to that in a moment as well, because that's kind of an interesting problem. Now, all of that's kind of hidden and should be transparent. You shouldn't have to know about what our network does. I guess what you should know about, if anything, is the useful stuff maybe that AARNet can provide to an end user. One of the things that maybe you've stumbled across is the mirror, the AARNet mirror. If you're downloading any Linux distributions, for instance, often they'll come from the AARNet mirror, and that should come down very fast because it's plugged into our network at multiples of 10 gig. It's distributed across our backbone. And that means that you're not pulling things down from the United States. If there's stuff that isn't on there and you think it really should be, we're always keen to hear back from you. Another thing which perhaps you haven't come across, but this is more kind of for researchers around Australia, we've built this product called Cloud Store, which is kind of like Dropbox, but really, really fast. Again, like Cloud Store, it's like the mirror, it's plugged in across our network. And so we built a CDN, a content delivery network, if you like, and if you are a researcher, then you have the right to 100 gig on this to store and transfer big files, and it just works. The reason I put this in is because my CEO tells me I've got to do a bit of marketing in these talks, and we don't have a marketing department, so for anyone to hear about Cloud Store, for instance, it involves me or somebody like me telling you directly. But anyway, it's worth giving it a try. Mainly, however, though, what people know AARNet for is the speedy network. So this is an example of one of my colleagues in Brisbane sucking down, doing a speed test. I don't know if you tried this from home, but you don't normally get 1.5 gig at home. He then managed to get 2.5 gig, and then my favourite output of all, he got, and this is not photoshopped at all, he genuinely got speedtest.net giving him a result of infinity megabits. So anyway, that's what we strive for as an organisation, very basically. Okay, but we're here to talk about SDN, software-defined networking. A very brief and somewhat artistic impression of what SDN is about for those of you who are kind of new to it. Essentially, if you go back not very long, a network device, you would call up Cisco and you would buy a router and you would install it. And that router would do 2 or 3 different things. It would pass traffic really fast. and it would work out where to pass the traffic to. And it would talk to other routers to work out between themselves for the whole network where to pass traffic to and from. So, but all of it was self-contained in the router. That means that the Cisco would have a lot of investment in making the traffic go in and out fast, but also a lot of investment in how to do that the smartest way. And I guess we're talking there, the data plane is the in and out fast, and the control plane is how you decide which way to shift the traffic. The idea of SDN, very simply, is to separate the two of them. And there are various reasons for doing that, which I'll talk about in a moment, but really that's what it comes down to, is teasing apart these roles and putting more dedicated gear to do that. And it opens up a bunch of flexibility around adding other layers as well. Now, the reason that that's kind of turning, from my perspective anyway, my belief that this is turning to an interesting thing is, I talked a lot there about the network that AARNet runs, for instance, and telcos or service providers all do that. But if you come to where we are today, the network's only really a building block. And the reason, and I think it's good that lots of people have never heard of AARNet, is because it just kind of works. You don't need to know about it. You're not being hit by congestion, or you're not being hit by unreliability. However, it's not sufficient anymore, I don't think, just using the network. Where we're heading now is adding compute and storage to that to turn into actual useful tools for the users, and then talking to users about how to use them. Which is why I included that little thing about Cloud Store, for instance, is because that's something that you, as a researcher or a staff member or a student, can actually use, whereas just knowing that you've got a 100 gig backbone across Australia is not really something particularly useful. So where we as an organisation are heading is very much down the path of building on the network. We're not abandoning it. We want to make sure that it continues as it is, but adding to it compute and storage as closely coupled to it, and some software tools on top of that that present interfaces or whatever, and then engagement to ensure that that those get used. And that's where the software-defined networking comes into it, because it provides potentially a glue between these different building blocks, the storage, the compute, and the network. It unfortunately doesn't help with user engagement, which is why there's still a place for me to come and talk, right? Software-defined presentation, that would be an interesting concept. So this is possibly the busiest slide that I've ever done, and I almost deleted it, but I'll try to work through it. Really, and this is the background to, again, why I think SDN is actually going somewhere, whereas if you'd asked me 3 years ago, I would have thought, oh, is it a gimmick, is it marketing? No, genuinely now I think that there is enormous potential here. When it comes down to it, that notion of teasing apart a Cisco router into a couple of building blocks, you either do it because you want to end up with something costing less, or something that works better. So, for example, Google, many years ago, started down this path, and they did it to a large extent for the costing less bit, because they were, they're a big organisation. They were buying so many switches and routers that eventually they thought, bugger it, we're going to build our own, and we're going to write the software ourselves, and it meant that they could do things enormously cheaper. Now, they ended up being able to do things better as well, which is great, but they're two kind of independent drivers here. The way you do it cheaper is you've separated the heavy lifting from the brains, so that heavy lifting can just be purpose-built as cheap as possible, but all it does is push data very, very fast. And at the same time, these days, virtualization and virtual machines and things like OpenStack and so on are providing compute at a much cheaper rate than it used to be when you had to buy a server every time you wanted to do something. So again, that means that your compute power can be much cheaper. On the better side of things, I guess this is something that I think is really interesting. This notion that you can get a single view of your entire network, which today is not the case. So today, routers and switches, they all work as little independent entities, and they talk to each other using BGP or OSPF or RIP or spanning tree, heaven forbid. But they end up with a kind of distributed notion of the network. Whereas here we've got the potential finally of, in the same way that when you sit in front of a server, that's a server, or if you sit in front of OpenStack, you get to see a view of a whole distributed infrastructure. Well, the network, finally, we can see it as an entire single thing and control all different bits of it through a single interface, rather than trying to say, well, I'm going to try to influence something over there and I don't really know if it will be influenced or not. But I'll talk about that in a moment. The interesting bit, for me at least at the moment, is why we're building an SDN testbed, and that is to address the fact that SDN is applicable, I think, across a wide range of areas. So data center in the cloud has already really taken off, mostly thanks to Google, I think, and AWS and similar organizations recognizing that within a data center it's very easy to make this work. And the campus is starting to take off a little bit more, because that's just a bit like a biggish data center. So at RMIT they've started replacing a lot of their campus switches by OpenFlow enabled switches. They've kind of paused because they're a bit ahead of the crowd there, and now they're waiting for scalability to catch up and reliability and so on. But I think that that's kind of a similar problem to data central cloud. What's undecided for me is that question of service provider or telco networks. Is this notion of SDN, of peeling the control plane from the data plane, does that actually work in a service provider type environment? So if you imagine a data center, you've got a server or a bunch of servers running the brains of your data center network, and you've got all of the switches doing all of the heavy lifting. Now that's fine because they're all sitting within a couple of meters of each other, so you just run multiple cables for redundancy. If one of them gets unplugged accidentally, it all just keeps working because you've got lots of connectivity there. But what happens if your brains are in Sydney and your switch is in Seattle, for instance? It's really easy for that to become disconnected. And so there's a whole bunch, I think, of research required now to decide whether software-defined networking is actually going to work as you go into bigger and bigger geographical spaces. And I'll talk about that in a moment as well. I'll skim through this, but all of these different ideas translate into a whole bunch of different whole sort of work areas of their own right. So just to pick some examples out of this, NFV is network function virtualization. That's the notion of, in a service provider, that you don't need any longer to provide a customer premise device, and if you want to give a customer load balancing and firewalling and some content filtering, each of them is a different box. These days you just do VMs for each of them, and you just pass the traffic bloop, bloop, bloop through each of the VMs, and you use SDN for that. Now that is a solution to one or two of these little boxes here, but it's a whole massive area in its own right. So the only reason I left this slide in was because I thought, for you guys, it's probably encouraging that there are a million areas that you could potentially get your teeth into, and none of them, many of them don't have actual solutions or optimizations or anything applicable to them. So anyway, I won't dwell on it. Ultimately, though, what we as a service provider are trying to do is please our users whilst making our administrators' life easy. And so the two sides of that I think are important to keep in mind. All right. So what are we doing in this space to, I guess I've talked a lot about why you might want to do SDN, and you're probably all convinced anyway, or otherwise you probably wouldn't be here. We, AARNet, along with various other universities, are trying to put in place some infrastructure to make it easier to do research in this area, because it's a positive area in that it's actually quite cheap and easy to get up and working, but on the other hand, working with a bunch of stuff in a lab is not quite the same as working out in the real world. And so what I'm keen on is to put in place some infrastructure that replicates the real world so that you can do interesting stuff with it. The background is that a couple of years ago, Vijay Sivaraman from the University of New South Wales and Craig Russell from the CSIRO and myself had talked about how they independently wanted to build an SDN testbed, and I wanted to do one as well, and so we decided let's do one. Vijay put together a linkage infrastructure equipment facilities grant to the ARC and was successful in that, and so this is where he gathered together a total of 9 universities plus the CSIRO, of which you'll see Swinburne is there, I hope. Yeah, there. And essentially what that means is that the ARC gave a bunch of money to Vijay to split into building network capabilities across Australia, plus a rack full of SDN gear at each of those 9 institutions. The intention being that that be used for simulating the internet, if you like, is what it comes down to. So step 1 was we at AARNet building our bit to this, which is kind of the central hub, I suppose. We got 4 NoviFlow switches. NoviFlow is just one of many vendors making just very fast, relatively inexpensive switches. And initially we've installed 2 of them in Sydney and Melbourne because it's easy to connect those 9 institutions to those. We've added a switch in Perth, and so you would have noticed University of Adelaide was one of those, and we're going to hang them off the Perth one just because we can. And then finally we've also installed one in one of our backbone sites in Seattle. Again, not very, well, it was mainly because we could, but it was also because I wanted to see what happens when you build these networks at a genuinely intercontinental kind of scale. So the fibre distance from here to here is something like 15,000 kilometres, and from there to there's another 4,000. So I'll show you how this is configured, but it's essentially a really, really big distributed router. The other reason for installing it into Seattle is because, as I've said before, we are neighbours with a whole range of other research and education networks, and a range of them are really keen to peer with us. A few of them have built similar test beds and are keen to peer with our test bed, which means that you'll be able to run experiments from here to your mates at University of Melbourne or to your friends at Florida International University. The idea is that it builds an overlay, little closed sandbox that reaches genuinely sort of internet size scale. So at the moment the Sydney Melbourne ones are up. We've got controllers. I think the next slide. Oh yeah. So we've stuck a couple of controllers into Sydney and Melbourne again, and so those 2 switches, their brains are separate to where they are. Both the Sydney and Melbourne point to Sydney. The Sydney and Melbourne switches point to the Sydney controller for their primary brain, but if that fails, they fail over to the Melbourne one. And then we're in the process, we've installed the Perth switch, and it'll talk back to Sydney and Melbourne again. And we've installed the Seattle switch, and I haven't heard from my colleague, but apparently last night it should be now talking back to its brain in Sydney and Melbourne again as well. And then the second step to this is to then add Swinburne and all the other universities to it. So essentially a layer 2 connection from whichever the switch we allocated to be the right one, extended out, handed off down in the basement of the university here, and then carried up via fibre to Jason's lab at the end of the corridor. In the case of Swinburne, the thing that we're waiting on is for that fibre to be terminated, at which point we'll be able to plug it in. I've got one of the bits of hardware in my bag to plug in down in the basement to the device where we deliver services to Swinburne as a whole. And then we bring up the connectivity from there to there. So it's at this stage we've got UNSW connected, we've got the CSIRO connected. There are 3 further, UTS, yourselves, Adelaide, and Macquarie, who are very close to connecting. We're aiming to have you all, if possible, done by the end of this month. Because more than anything, it's fun building things, but it's more interesting to put the infrastructure out there for researchers and staff and so on to actually use. That's really what this is about. Now, if I was to dive in a little bit more as to how that thing works, I've mentioned about controllers and so on. This is actually what it looks like from a logical perspective. So if you imagine, and this is taken, so we're using an open flow controller called ONOS, which is brought out by OnLab, which is an organisation in the States associated with Princeton. And we're using NoviFlow hardware switches, but in reality we could be using there's a whole range of switches we could be using, and for that matter there's a bunch of different open flow controls we could be using as well. We just chose that because it was the easiest one to make work at the time. One of the things, and this is my own mini version of research I guess, is discovering that OpenFlow just doesn't work very well yet. So you think, okay, I'm going to take my switch, I'm going to take my server, I'm going to stick an OpenFlow controller, and it'll work, right? It works with Cisco, you turn it on and it works, but no, with OpenFlow controllers there's a vast variety of respect for the standard or for bugs or whatever. So there's we ended up going with ONOS just because it kind of worked, and they were really enthusiastic to make it work better. So we've had a lot of support from them. But so so this part here is the equivalent of our SDN Testbed. You can imagine Sydney, Melbourne, Seattle, and Perth. They interconnect to each other in a sort of a square, I guess, and then they've got a connection, an out-of-band connection up to a couple of VMs. There's VMs that run overflow controller software, and that's what provides the brains. And then that overflow controller software runs an app called SDN IP, which it takes those 4 switches and turns them into a distributed router, makes them look like a router. And in order for that router to be able to talk BGP, we've got a second set of VMs, those blue ones up the top, which are running Quagga, which is a BGP open source route daemon. And so it makes these 4 switches look like not only a router, but a router that's able to talk BGP. And then via those connections, which I showed in the last one here, the connections out to each of the universities, each uni kind of has or will have a similar setup. So imagine this is Swinburne. You'll have a Pika 8 switch, not an overflow, a Pika 8 switch running a different overflow controller. It's also by OnLab, but it's called Atrium. It's designed, instead of taking multiple switches and turning them into a distributed router, it takes a single switch and turns it into a router. But you know, same concept really. So you can imagine that if you drill down into the Swinburne setup, it'll end up looking pretty similar to that. So switch, overflow controller, BGP speaker, and they all just talk to each other via connections. I forgot I'd left this in. I'm not sure that this is going to add anything, but I thought I should have at least one animated slide. That's important, isn't it? So to go back, you connect your Swinburnes and your University of Adelaide and so on. So this router here, which is your Pika 8 switch, will send a BGP update into the network, and by magic it arrives on the Quagga VM. It says, okay, so now we know about Swinburne, and it pushes that information across to the ONOS Openflow controller, which then pushes that information down into these devices. So I guess this was really just to kind of show, rather than you've got a Cisco router or a Juniper router doing all that stuff mysteriously inside, well, in this case you can genuinely see you've got the switch here, you've got the BGP daemon here, you've got the overflow controller and the routing app here. You can actually watch the traffic going between them. It's very much kind of teased apart and separated apart. You can also watch when it's not working and you can't tell why it's not working, but that's, you know, the idea also is to have that visibility. Okay, so to finish off, I thought and this is the bit where I'm hoping to generate some thoughts and ideas and whatnot from you. We've put in place this infrastructure. Essentially what it means is that here at Swinburne you've got an OpenFlow capable switch, then you've got a bunch of servers, and you can configure them to do kind of what you want. They are a little island which talks back to our central island, and then around that central island are other islands, the Adelaide Uni or the UNSW. So there's a blank slate there, able to be used for a range of things. So I thought I'd throw out some of the ideas that I'm interested in, but there are a million others that hopefully this will kind of evoke in you. So one of the things that we've already done was, and this was a precursor to this setup, we had a couple of Corsa switches. So they're a bit like our Novi flows. They're capable of doing 100 gig speeds, which is something obviously of interest to me. What we wanted to verify here, and this was a precursor, I guess, to the setup that you'll have at Swinburne and others. We wanted to make sure that you could take a switch and turn it into a BGP router and it would just work, because if you can't do that, then you're a long way behind your kind of competition in Cisco and Juniper and so on. So we got a Corsa switch in Sydney, running ONOS, and a Corsa switch in Seattle, running Ryu, different OpenFlow controller, different BGP talker, and connected them via point-to-point service, and thankfully it just came up. The BGP session came up. They were able to exchange routes. I don't think we actually sent any traffic, but we could see that you can simulate a router, which is a good thing. Now the question is, where do you go to from that? Some of the more interesting kind of questions are where you focus on in terms of research directions, and that's this notion of intra versus inter-domain SDN. So I mentioned before that there's been a lot of work in the data center and a certain amount of work in the campus. All of that is essentially intra-domain SDN, as in you own the data center and all of the stuff in it. It's all your gear. You can control any of it, and there's no issue with jurisdiction or whatever. Whereas if you're talking about AARNet and our neighbour Internet 2 in the United States, or even Telstra or Optus here in Australia, we're neighbours on the internet with them. We don't have any control over their network, or vice versa. The only touch point that we have is through things like BGP, where at a routing level we can say, well, we know where Swinburne is, they're on this side of us, and we tell Telstra that, or we tell Optus that. And they go, oh, okay, so we go to AARNet for Swinburne. And there's a little bit of kind of guiding of paths, for instance, that you can do at that level using BGP. But there's no direct connection where Telstra has an API into the AARNet network to say, I want to go this path to Swinburne or that path to Swinburne. That just doesn't exist today, for good reasons, right? We don't want Telstra, and I've got a friend from Telstra in the crowd, hence I'm picking on them. But I don't necessarily want Telstra to have control of my network. I'd rather keep control of my network myself, partly because they might be malicious, partly because they might be incompetent. I shouldn't be drilling on Telstra here. I should just say, service provider X, we don't necessarily trust them to look after our network. But that's also because there isn't any system in place to put controls or boundaries around that. Now, I think that inter-domain SDN is a really, really interesting idea, partly because no one's kind of played with it, and partly because there's an enormous amount of potential there. And so we've built the testbed to enable that. So the AARNet central testbed is one autonomous system, if you like. The Swinburne lab is a different one. We can reconfigure it if we need to make it all one system, or provide slices of the whole thing. Again, so you've got lots of parallel single systems, but initially at least we thought the most interesting way to set it up would be to simulate the internet and then build on that to see what you can do better. So an example of where I would still like to see some work done on intra-domain SDN, and this is in a service provider network. One of the problems that we have is, as I mentioned before, not much capacity that way and lots of capacity that way. The reason this is a problem is because an example is there's an organisation called Salesforce which provides customer resource management, CRM solutions, and they host their gear in Singapore. Lots of universities and of our various other customers use that tool, and it's a bit like Google Docs or I don't know, Microsoft Office 365 in the sense that you connect to it and you've got an interface and you update things and you download things and you change things, whatever. And that works fine if the path from you to it is short, but it works badly if the path is really long. Now our problem is that, so we will route people across the shortest path to that application, and it'll work until suddenly a big researcher at Swinburne starts downloading too much stuff from Asia, and that path gets congested, at which point or if that path goes down, in which case we'll fail them over to this path, and suddenly it starts working worse, even though it's less congested. And if this one's congested, then we'll send them to Seattle and back, and it works much worse, even though there's no congestion at all. It's just simply that it's going like 30,000 kilometres instead of 6,000 kilometres. So I would really like the intelligence in our network, rather than it being a manual process where customer calls us or we notice congestion or whatever. I'd like our network to be smart enough to say, okay, under these circumstances, I want this sort of traffic to go this path, but under these conditions, I'd rather it take the second worst path, and for particular sorts of traffic, like the physicists downloading an entire library worth of stuff, I don't care about their path. I just want them to go down the biggest pipes altogether, and if they have to go all the way around the world and back again, too bad, they don't actually care. So more intelligence in our network, so taking policy and matching it against actual conditions is something that I'm really interested in seeing if SDN has a part to play in that. So that was intra, because all of that's within our control. That's me deciding which of my paths I want the traffic to go. Inter-domain is where it does start getting interesting. So this, I guess, is how the research and education kind of internet looks to me. Again, I've left off the commercial telcos because they don't connect or they don't play a part in any of the paths for you to get to MIT or Berkeley or whatever. For us, it's a bunch of clouds. RIANS is the New Zealand network, Internet 2 is the American, ESNet is American, Géant is European. I see the potential there for much more control across network boundaries. So to take an example, what I talked about there within our network of do I go the short, fast path or the longer but uncongested path, I'd love to be able to have that sort of control on a global basis. And really this comes down to IXV's Internet Exchange Points, which is where we touch with other networks. So we touch with commercial providers at an Internet Exchange Point, we touch with R&E providers. I'd love the capability for them to present an API or something so that, and it may be a paying sort of service, that I can pay some IXP on the far side of the world to present me with the ability to actually deterministically guide my traffic one way or the other. Now, I'm going to throw that one to you all because you're much brighter than I am, because that's a really, really hard problem. If I say I want my traffic to go this way, and I'm paying good money for it, and 3 million other ISPs are saying, I want that too, then the links explode and nobody gets what they want. So there's all sorts of issues around that. And the reason that the internet works the way it does using BGP is because it just works. It takes some of that complexity out of people's hands. So I'm not saying that this is necessarily something that's going to be possible, but the notion of and the reason that I think this is going to be useful is in the same way that we put storage and compute all the way around our network, I'd love to have that same storage and compute all the way around the world and to be able to guide traffic to and from it in a more intelligent way than is currently the case. So the notion of being able to control other people's networks and vice versa in a way that doesn't break the entire internet, I think is a potential, has got a lot of potential too. And then finally, scalability. So we, with our network, tend to, if there's a difference between us and TPG or AARNet, it's in how fast we have to push traffic. So as I say, our backbone is 100 gigabits per second. Customer connections are all, they kind of start at 10 gig, so it's very different to your 20 meg connection at home. It means that things need to scale a lot. So there's a lot of work done on at the moment on how you get data really fast in and out of universities. So I talked about the physicists, but this goes for genomics researchers, and it goes for astronomers, and it goes for a whole range of disciplines where they're generating huge amounts of data. Now getting that data in and out of or across a network doesn't always work very well. Protocols like TCP and others are subject to problems with latency and subject to problems with packet loss. So the notion of building a network that can more intelligently shift traffic around, maybe shift compute closer to the data it's meant to be computing on, or at least be able to get the data there without taking congested paths, is a really important one. And then tied in with that, then as you're pushing huge amounts of data through paths that you're not letting the campus IT people protect with firewalls and so on, there's a question of security comes up, and there's some really interesting work on how you secure very, very high bandwidth transfers. And this is an example one, SidePass from the University of Indiana. They're working on the idea of, okay, if you're filtering traffic through a firewall and you ramp up speeds, and suddenly you start to push traffic through that's purely research traffic and you really don't need to firewall it, how about we intelligently find a way of switching around this? So it's like a scaled down version of my problem with the Singapore versus the long path round. It's like taking, how do you say, okay, this is astronomy traffic, it's going to be going at 100 gigabits per second, I can't firewall that. How do I take it away from my firewall? Because I don't want to firewall that anyway, it's just physics or astronomy traffic. So the notion of intelligently switching traffic onto a different path based on recognizing what that traffic is, and then being able to farm it out into into very scalable kind of intrusion detection farms. All right, I just jumped around to about a million different things, none of which relate to each other. Essentially, with the testbed that we're building, it's as I said, it's a blank slate. It's there to enable you to do your job. I've thrown different ideas that I think are kind of interesting at a very high level, but really it comes down to you picking things that you want to do, and me building this network or altering this network along with the different universities so that it works in a way that is useful to you. So we can connect more universities. We started with 9. We want to add more to that. We want to encourage collaborations. That's an important one. So between yourselves and UNSW, or between yourselves and MIT, for instance, that to me is really important, opening up the possibility to collaborate internationally and nationally. And basically for you to do interesting stuff, I think, is really what it comes down to. That's it from me.
Thank you very much, Dave. We do have some time. The light's still on, so we can record some questions and answers. Or we can pause that if there's any questions people don't want to have the answers recorded to. But does anyone have any questions for David?
In case nobody wants their question.
Yeah.
So you said interdomain is interesting, right? So you talked about this world where someone else will ask for a specific path through your network. How do you think that's going to work once the commercial guys realise that you're essentially exposing internal information about your network to your potential competitors? It becomes very easy for me to start probing your network to see if you're overloaded, underloaded, are you needing your SLAs? Because I can just ask for random paths, and if you say yes, then I know something about you. If you say no, then I know something else about your internal infrastructure. I can start doing hundreds of probes a minute just to regularly monitor your network internally. That's commercially valuable information. Your case being AARNet, you probably don't care so much, but there's a lot of really commercially vital networks wanting to expose their internal structure via some SDN.
No, it's true. That's something that that I've noticed in the R&D world come up quite a bit, is that disconnect between what you're talking about and which is kind of commercial realities, and the openness and collaboration of the R&D world. Even at AARNet, actually, we are faced with that problem. We don't. Several years ago, we took down our weather map. So we had a weather map illustrating all of our paths and the load on those paths. And most R&D networks actually put one up, and they look really good, and they're very useful for troubleshooting. But our ops guys decided that they didn't want to, almost for that reason that you were saying, because it provides commercial information which you don't necessarily want to give away. I don't have an answer to that. It's one of the many issues with this as a possible offering. There are ways, I guess, of kind of not obfuscating, but aggregating, if you like. So, if you could take our network, which is quite a rich mesh of links, and drop it down into kind of you could say you've got a path to Perth, a different path via Darwin, and a third path via Brisbane or something. So you kind of simplify it down, but it still doesn't hide everything. It is a very good point.
Just on that topic, I guess today between service providers, there are the notion of inter-AS VPN, so that sort of trust is already in operation through that kind of network stuff anyway. So I guess if that sort of technology is already available today, and is that trust between two ASs such a concern?
I think usually like a layer 3 VPN that extends across service providers still has clear sort of delineation, doesn't it? Like you're handing a VLAN or a bunch of VLANs. At the most, you might be exchanging MPLS labels, but even quite often you don't do that because that's kind of too much interaction between the service providers. So it's often just we'll bring this list to you and we'll hand them to you and you'll pick them up. And again, you're just talking BGP or something. So at least I'm not aware of any instances where you actually do merge sufficiently that you can control paths and so on the neighbouring service provider network. But it would be, so yeah, I guess what I'm talking about is going that next step beyond what exists today.
Yes, someone, I don't know, but I would imagine when something like that happens, it happens after months of negotiation between lots of people.
Moderately.
Not an API that someone can just log in, pay some money with a credit card.
No, I mean it's a moderately standardised kind of service. In many cases, it's say for instance a global service provider. I used to work for one called Equant or Orange Business Services, and we had an international network, and we'd just stop at a couple of places in each country, and then we'd partner with Telstra or Optus in Australia and partner with France Telecom in France. And so if you wanted to deliver a service from an end customer to an end customer, then as a matter of course you had to set up like a VPN on our network, which would be extended across those local service providers. So it's certainly not an entirely manual process, but it's still very delineated compared to what maybe it could be. But yeah, I totally agree that there's enormous complexity around it. That's an area that the VJ from UNSW is really keen on working on in terms of software-defined IXPs and so on. So to a certain extent, I'm throwing it in there. Absolutely. Well, it's good to start at one extreme and maybe derail back somehow.
I wonder if the API, like the ability to, you might be able to develop more authentication or security into such an API than you get with BGP.
Sure, and you would like to think so. One, and this is again that question of coming from an R&E perspective. Often we kind of forget to add security to things or build security into things because we tend to work in a fairly trusted environment. Whereas, so that as part of this ANZ sort of SDN effort, there's various meetup groups and so on, and the commercial guys, the first thing they always say is, oh, are you going to actually build some security into this right from the start, because you can't kind of tack it on at the end. But yeah, I'd like to think that in the form of an API, you would be able to add whatever form of authentication or authorization, whatever, visibility if nothing else, compared to what BGP can do, which is rich and is used in various ways, but maybe is a little limited in that way.
Any other questions for David? Just before we think, if there's anyone here at Swinburne or anyone else who wants to talk to us here at Swinburne about utilising the net, I'm probably the person to get in touch with as the lead person on the Swinburne side of this SDN Testbed. And as David said, we are relatively close to being up and running. We're just waiting for some Sparkies to come in and put connections at the end of our fibre. As I told David the other day, they came in last week, I showed them where it was, and they pointed and talked a bit, and they wandered away. I haven't seen them since, so hopefully they'll come back at some point and actually finish the fibre off, which is just coiled in the roof at the moment. But I'm the person to come and talk to if that's what you are interested in talking about. Once again,
we can forward the recording to the Sparkies, can we?
Thank you very much, David.
No worries, thank you.